Good morning, champs. Today we solve one of the load types that students often find intimidating, the trapezoidal distributed load. The good news is that a trapezoid is not a new problem. In fact, it is simply a rectangle plus a triangle. Once you recognize that, the entire problem becomes straightforward. Consider a beam carrying a trapezoidal distributed load. The load intensity starts at 2 kilonewtons per meter on the left side and increases linearly to 8 kilonewtons per meter on the right side. The beam length is 6 meters. Our goal is to replace this load with a single equivalent force and determine where that force acts. The first step is decomposition. We split the trapezoid into a rectangle and a triangle. The rectangle has an intensity of 2 kilonewtons per meter over the entire length. The remaining triangular part has a height equal to 8 minus 2, which is 6 kilonewtons per meter. Now we calculate the force from the rectangle. The equivalent force equals the area of the rectangle. Therefore, the force is 2 times 6, which equals 12 kilonewtons. This force acts at the center of the rectangle, 3 meters from the left side. Next, we calculate the force from the triangle. The equivalent force equals the area of the triangle. Therefore, the force is 1/2 times 6 times 6, which equals 18 kilonewtons. Since the larger side of the triangle is on the right, the force acts 1/3 of the length from the right side. This corresponds to 4 meters from the left side. Now we combine both forces. The total equivalent force is 12 plus 18, which equals 30 kilonewtons. To determine the location of the resultant force, we take moments. The location is calculated by dividing the sum of the individual moments by the total force. Substituting the values gives a location of 3.6 meters from the left side. Our final equivalent load is therefore a force of 30 kilonewtons acting 3.6 meters from the left end of the beam. The most important lesson is that trapezoidal loads do not require new formulas. Simply split the load into shapes you already understand. Calculate the individual forces. Combine them. Then use moments to determine the location. Engineering statics becomes much easier when complicated shapes are broken into simple pieces.